Welcome. This video is a slideshow presentation from the Unicon series of informational slideshows. This presentation provides a high-level overview of the Unicon process of incremental reengineering. It is an optional process within the Unicon component conversion methodology. This optional process can be used when the process to directly achieve the required objective carries a very high risk. The option is to take low risk and minimally disruptive incremental steps to achieve the required objective. This is what we refer to as incremental reengineering. For example, an incremental reengineering approach can be very successfully used to remove the very high risk levels that are normally involved with performing COBOL to C# or COBOL to Java projects. COBOL to C# or COBOL to Java projects are notoriously very high-risk projects, and it isn't very difficult to understand why. In these projects, absolutely everything goes through dramatic change, including every data storage definition and every logic statement on every line in the COBOL program source code. Additionally, the COBOL source code includes many commonly used COBOL facilities that C# and Java just simply cannot do. Every data type in the COBOL program must be replaced by a C# or Java data type. But it isn't a simple one-for-one replacement. The COBOL data type of comp can be replaced by the C# or Java data type of integer. But C# and Java have no direct replacement for the COBOL data types of comp3 and signed included. When a workaround replacement is decided upon, it is invariably of a different storage length than the original COBOL field. Redefines and data field groups are commonplace in COBOL, but they have no corresponding direct replacement in C# or Java. And every COBOL statement must be replaced by a C# to Java statement, but the goto statement in C# does not function the same as the goto statement in COBOL, and Java does not have a goto statement at all. Sequential files are the backbone of most mainframe batch jobs, but C# or Java cannot handle the data constructs in a typical COBOL sequential file. All COBOL programs move data around in the program in data groups. This is a data level number that is subdefined into subordinate fields of various data types. A data level that has subdefined fields can be moved to a single level field in COBOL. The COBOL program can move any data group of various subfield definitions into a single level field. C# or Java cannot do this. Because of the massive changes that are required to migrate the data and the code, these projects require much longer timeframes to complete. 3, 4, or even 5-year project timeframes are not uncommon. In particular, the testing process must be very thorough to fully test all the changes that have been made to the data and the code. But these long timeframes can encompass significant ongoing changes to the production source code, which must then be incorporated into the converted code set. And there could be considerable external technology changes in this timeframe. And when the application is finally ready to implement, it must be implemented in one big bang. None of these are conducive to a low-risk project. These types of projects can significantly benefit from an incremental reengineering approach. So let's consider an example of a COBOL to C# migration project, specifically to migrate the applications on a Unisys ClearPath MCP mainframe to Windows. The programs are written in COBOL. The screens are either SDF, ePortal, or Web PCM, and the data is stored on a DMS2 database. The JSON files are written in WIFL. The project is to convert the applications to run on Windows. Using the Unicon component conversion process, the screens are converted to web forms, the programs are converted to C#, the data is converted to SQL Server relational tables, and the WIFL are converted to .bat scripts. This is a very high-risk project. If the project had converted the programs to Visual COBOL instead of C#, it would have been a very low-risk project. It is interesting to note that the screens, database, and JCL would have been converted the same in either case. In both cases, the data would be stored in SQL Server database, and the screens would be web forms. So the supporting infrastructure of the migrated application, whether the programs were converted to Visual COBOL or C#, would be the same. But converting the Unisys MCP applications to Visual COBOL is a very low-risk project, and converting this to C# is a very high-risk project. We can completely mitigate the high risk of migrating to C# by performing a phased migration. If we initially convert the applications to run on the Windows system as Visual COBOL programs, get that up and running as the production system, we can then convert the Visual COBOL programs to C# programs on a one program at a time phased philosophy. Then we can completely remove the risk of directly converting COBOL to C#. We can convert the Visual COBOL programs to C# programs on a one-at-a-time basis because Visual COBOL is a .NET programming language, fully implemented into the .NET framework, exactly like C# and VB.NET. When C#, VB.NET, and Visual COBOL programs are compiled, they all produce the same CIL bytecode, Common Intermediate Language. All the CIL programs run under the CLR, Common Language Runtime. That is why C#, VB.NET, and Visual COBOL are fully interoperable. The one-at-a-time conversion would, of course, actually be groups of interrelated programs being converted at a time. The next group of programs can be converted and fully tested as a small group of interrelated programs before they are implemented into the production system. The main benefit of this incremental reengineering approach is to remove the very high risk of performing the direct COBOL to C# migration project. But there are some significant side benefits to be derived from this incremental reengineering process. Implementing the Visual COBOL migrated applications on Windows and shutting down the mainframe occurs much earlier than is possible in a direct COBOL to C# project. It places the data into the SQL Server relational tables and implements a web form front end years earlier than a direct COBOL to C# project would do. This enables the new SQL and web form facilities to be used in development. For example, any SQL utility such as SQL Reports or Crystal Reports could be used to directly create reports from the database tables, or the web forms could be modified to provide a better user interface. Once the Visual COBOL migration is implemented as the new production system, then the incremental reengineering process enables the strategic conversion of the Visual COBOL to C#. The conversion of the programs can be performed in any order. The programs that are most beneficial to be converted to C# can be performed first. This enables the available effort to be placed where it will provide the most benefit. Incremental reengineering enables a true conversion to C#. In a direct COBOL to C# project, it is often paramount to get off the mainframe as quickly as possible to obtain the savings that will be used to recover the cost of the migration. This puts significant stress on the project, and the quality of the converted C# code often suffers as a consequence. But the conversion of the Visual COBOL programs to C# can now be planned as a process that is not under the gun, and it can be performed in a logically planned and carefully managed process, which leads to the generation of much better C# code. The technique of converting the COBOL directly to C# or Java, whereby the statements in the converted code are written in the required C# or Java syntax, but the statements are coded to call classes that mimic or emulate the original COBOL statements, should be avoided at all costs. This technique leads to completely unmaintainable converted programs that also have extremely poor runtime performance. Unicon's view is that if the converted application is difficult to maintain and enhance, then the conversion project isn't worth doing, and that the converted application must be at least as easy to maintain and as fast to run as the original mainframe application. The incremental reengineering process also provides an overall lower project cost. Let me explain what I mean by this. A typical COBOL to Visual COBOL project takes 6 to 12 months and costs $500,000 to $1 million. Converting the same applications from COBOL to C# typically takes 2 to 3 years and costs $2 to $3 million. The Unisys MCP mainframe, in the meantime, could be costing $5 million a year to run. Converting to Visual COBOL in 12 months instead of 3 years converting to C# will save $10 million in years 2 and 3. Therefore, the entire cost of incrementally converting the Visual COBOL to C# will be more than paid for by the savings obtained in the running costs of the Unisys mainframe. Thank you for viewing this video. I hope it has been useful. If you would like to see any of the other Unicon informational videos, please contact us and tell us which subject or subjects you would like to see.